This is Mr. Herman, and this video will be about similarity. Now, the past two videos we've looked at is we have talked about scale factor and dilation. Now, these really feed into what similarity is. So we're going to set up a definition of similarity. Okay, so we have similar figures when all corresponding angles are congruent in all corresponding sides are proportional. Okay, now if you think back to our dilation video, we said that all angles have to be the same and our sides are proportional. In similarity, here's our definition. They're proportional by the scale factor, which we talked about in our last video. Okay, so we're going to look at those in a minute. Before we get there, we're going to look at some notation. So our similarity notation, if we have two figures that are similar, we're going to have this squiggle in the middle. Okay, so we've seen the squiggle with the over the equal sign, that's congruent, but this right here you read as is similar to. Okay, we'll put that in quotes. Is similar to. So I read this as triangle ABC is similar to triangle DEF. And that tells me that those two triangles have angles that are congruent and sides that are proportional. All right, so let's go and look at an example. So if I've got triangle ABC, and let's see, we've got triangle DEF. I've got this triangle here. I get my angle markings going on this one. Okay, so there's triangle ABC. Try to clear that up for y'all. There we go. Okay, we've got triangle DEF over here. It has the same angle markings. So what we know right now is that these two triangles could be similar because we have A, B, and C have these angles that are congruent to angles D, E, and F. Okay, so if I were to go through here, I could make the statement of angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Okay, so that tells me that I have similar triangles. Okay, now what I can also do is I can also look at a dilation. Before we leave this one, let's make a similarity statement. Triangle A, B, C is similar to triangle D, E, F. Now let's go ahead and look at a dilation that we've seen before. Okay. So in our dilation video, we took a look at this dilation where we had quadrilateral D, E, F, G and quadrilateral D prime, E prime, F prime, and G prime. Now, if we take a look at our side lengths, we have to find a common scale factor. Okay, so I'm going to make that note here. If there is a common scale factor, the two figures are similar. Okay, and we'll talk more about this property in our next video that we'll talk about our similarity theorems. Okay, so let's go ahead and check here. we have a length of 1, 2, 3, 4, a length of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and our long side appears to be 6. Now if we look at our small rectangle, we've got 1, 2, 3. On our short side, we've got 2. Our long side, we have 3. Our short side, we have 2. Okay, so we went from 4 to 2. That'd be times 1/2. 6 to 3 times 1/2. 4 to 2 times 1/2. And 6 to 3 times 1/2. Now, since we know that we had this scale factor over here, these have to be similar quadrilaterals, okay, or similar rectangles. So this down here we have quadrilateral DEFG is similar to quadrilateral D prime, E prime, F prime, G prime. If we make a dilation, the two figures are similar. Okay, I'll say it again and I'll write that down. If we perform a dilation, the two figures are similar. Okay, now you have a few questions to answer about similarity.